Hello students, so these are the corrections for assignment 1C. Let's get started. So the first question is the numbers 1080, 1188 and 1815. They're written the product of their prime factors we are given, right? 1080 is 2 to the power 3 times 3 to the power 3 times 5. 1188 is 2 to the power 2 times 3 cubed times 11. And 1815 is 3 times 5 times 11 squared. So what we are trying to do is to find the greatest whole number that will divide these three numbers exactly. So what are we doing here actually? Well, we are actually trying to find the HCF or the highest common factor. So by listing them out in a form like this, we can just do a quick comparison of each of the factor. So if you look at the prime factor 2, we realize that 1815 does not have prime factor 2. Therefore, it is not in the HCF. Then we compare prime factor 3. Well, we have 3 to the power 3 for 1080 and 1188 and 3 to the power 1 for 1815. Therefore, 3 to the power 1 is part of the HCF. Then we'll look at the factor of prime factor 5. We realize that it's not inside the 1188, and the prime factor of 11, which is not in 1080. Therefore, the greatest number is actually 3, which is the HCF. Well, next question, another practice. This time round, we have the three numbers 1120, 1276, and 1450. Again, their prime factors has been given, the prime factor form. So this time round, we want to find the smallest non-zero whole number that is divisible. So take note of the keyword, right? Numbers as divisible, which means that this time round, instead of trying to find the HCF, we are trying to find the LCM. So same process, but this time around for LCM, so we list out the numbers in this manner, compare each of the prime factor, and for LCM, we want the prime factor with the highest power. So if you look at prime factor of 2, we find that we have 2 to the power 5, 2 to the power 2, and 2 to the power 1. So we collect 2 to the power 5 for the LCM. Then for prime factor 5, we have 5 to the power 1 here, no 5 in 1276, and 5 squared in 1450. So we collect 5 squared for the LCM. Then for the prime factor 7, well, we have a 7 in 1120. We don't have 7 in the other two. Therefore, 7 to the power 1 is the highest power over here. So LCM there. Same for 11, and finally for 29, right? So we work that out. That will be 1,786,400, and that is the smallest number that's divisible by all these three numbers. Okay, next one. Let's find the highest common factor. The highest common factor of two numbers is 175 is given. The lowest common multiple also given as 12,600. So both numbers are greater than their highest common factor, right? So let's that means we cannot have one of the two numbers that we are trying to find which is equals to the highest common factor. It has to be larger. So do a quick comparison once again. So let's say the two numbers are, just call them A and B for now. You'll find that this is the HCF is 2 to the power 0 because there's no 2. 3 to the power 0 times 5 squared times 7. LCM is 2 to the power 3 times 3 squared times 5 squared times 7. So what happened? Well, for A and B, the 2 to the power 0 for HCF must go to one of them. 2 to the power 3 from the LCM will go to the other number. So let's give them to A and B for now, right? In the second prime factor 3, again, we have 3 to the power 0 for HCF, 3 to the power 2 for LCM. So I'd like to sort that out, right? Because the reason is because if we continue to give the smaller value to A and the larger value to B, we will end up with A being equals to the HCF and B equals to the LCM, which is not what we want. So this time around, the larger value, 3 to the power 2, we give it to A, 3 to the power 0, let's give it to B. As for prime factor 5, both of is 5 squared, so 5 squared goes to both A and B, and 7 goes to both A and B. So from here, we can work it out. A is actually 1575 and B is 1400. Right, next question. So Sufan needs to pack 171 pens, 63 pencil, and 27 erasers equally into identical gift bags. So we are supposed to find the largest number of gift bags and then the number of each item. So the gift bags, of course, we will have less gift bags needed compared to the number of items. So we are trying to find the HCF in this particular instance. So we have the three number 171, 63, and 27. Again, using the technique that has been practiced a couple of times in the earlier questions already. So we should get the HCF as 9, right? 3 squared. That means the number of givebacks is actually 9. So since this is a word problem, please do have the good habit of always giving the context or a final statement. And then for part 2, to find each of the items, we just take the total number of each item, divide by the number of givebacks, right? So very quickly, we have 171 divided by 9, which give us 19 pence. 63 divided by 9, we get 7 pencils. And 27 divided by 9, we have 3 erasers. Okay, one more question here. Sweets are sold in packs of 120, while mini chocolate bars are sold in packs of 18. So Siti bought the same number of sweets as mini chocolate bars. Find the least number of packs of sweets that she could have bought. So what's happening here? We are actually trying to find the LCM, right? Because the LCM would be the value that or the number of the mini chocolate bars and the sweet. So by finding the LCM, which we already had some practice, we list them out. So we get 2 to the power 3 from the 120, 3 to the power 2 from the 18, and 5 from the 120. We get 360, right? So 360 is the total number of sweets. Now the question asks for the least number of packs. So since they come in packs of 120, so 360 divided by 120, that gives us 3 packs of sweets. Right? Now here comes another interesting question. The numbers 528 and 540 written as the product of their prime factors are 528 equals to 2 to the power 4 times 3 times 11. 540 is 2 to the power 2 times 3 cubed times 5. So what are we supposed to do? Well, we are supposed to find the smallest non-zero whole number, h, for which 528h is a multiple of 84. So we are actually looking for the LCM, right? Because the LCM of 528 will be 528h, right? Because 528 will be one of its factor. And of course, the LCM of 540 is definitely a multiple of 540. So it actually satisfies both of these conditions. So finding the LCM, so we work it out. LCM is 2 to the power 4 times 3 cubed times 5 times 11. That gives us 23760. So that means that 528 times h is actually 23760. H will be 23760 divided by 528. That gives us 45, right? And looking at the second part of the question, this time round they want the smallest whole number k, for which 528 divided by k is a factor of 540. So this time round, instead of looking for the LCM, we are looking for the HCF, right? The highest common factor. We want a number that is a factor of 528, because if I can divide by k over here, definitely k is a factor of 528, right? And also the factor of 540. So the HCF is actually 2 to the power 2 times 3 times 12. 2 to the power 2 times 3, which gives us 12. And that means that 528 divided by k is actually 12. So what happened? K is actually 528 divided by 12. That gives us 44. And that is how we can work out these type of questions. Right, one more. A class has between 30 to 40 students. Each boy in the class brought 15 chocolate bars for the class party. The chocolate bars are shared equally among 20 girls of the class and their form teachers. There are no leftovers, right? So how many students are there in the class? So what's happening is we know that there are actually 20 girls. We need to find out how many boys, right? If we know how many boys, then we will be able to know how many students. So how do we know how many boys? Well, we know that each boy brings 15 chocolate bars and share among 20 plus one form teacher, so shared among 21 people. So we are looking at the LCM of 15 and 21 over here, right? So 15 and 21, find the LCM, work that out. Okay, that will give us 15, 3 times 5 times 7, which gives us actually the number of chocolate bars, right? So what happened is we end up with 15 times 7. That means we need to have 7 boys to bring 15 chocolates each in order to distribute it properly. However, the tricky part of this question is that the number of students is actually between 30 to 40. Therefore, if there's only 7 boys, then there will be only 27 students, which means it doesn't work, right? So we need to actually get a multiple of the lowest common multiple. So from here, we actually need to check that we need the number of boys to be actually in a multiple of 7, which means we actually multiply this 15 times 7, multiply it with the smallest prime number that we can have, and see whether it fit the criteria of 30 to 40 students. And true enough, when we multiply by the smallest prime number, which is 2, the numbers are perfect, right, within the range. So number of boys we want is a multiple of 7. So since the number of students is supposed to be between 30 to 40, number of boys we want will be 14, right? Just multiply by 2. So 20 girls, 14 boys, that gives us 34 students. How about the number of chocolate bars now? Well, the number of chocolate bars their form teacher received. So the number of chocolate bars now is 14 boys times 15. So this gives us a total number of chocolate bars divided by 21 people, right? Because 20 girls and 1 form teacher. So each of the girl and the form teacher actually received 10 chocolate bars. Alright, hope you have been successful with this set of questions. Have a nice day.